Welcome to the engine room of machine learning, calculus. Every model that learns using one idea from this chapter. The derivative. It sounds abstract, but it is nothing more than the steepness of a curve at a single point. Let's see it. Start with something you know, the slope of a straight line. Rise over run how much it climbs for each step across. A steep line has a big slope, a flat line a slope near zero. Simple enough, but what about a curve whose steepness keeps changing? That is the puzzle the derivative solves. Take the curve y equals x squared and pick the point at x equals 2. We cannot use rise over run directly, there is only one point. So we cheat, pick a second point nearby and draw the line through both. That connecting line is called a secant and its slope we can measure. Right now it reads about 4.5. Now the magic. Slide the second point closer to the first. Closer. The secant line pivots and its slope settles down, 4.2, 4.01. As the gap shrinks to nothing, the secant becomes the tangent, the line that just kisses the curve. Its slope here is exactly 4. That settling value is the derivative. It is the slope of the curve at a single point, the instantaneous rate of change. We write it f prime of x or dy dx. For y equals x squared, the derivative turns out to be 2x at x equals 2, that is 4, exactly the number the tangent gave us. Here is the leap. The derivative is not just one number, it is a whole new function. Feed it any x and it returns the slope there. Plot it and you get a second curve tracking the steepness of the first, rising where the original climbs, 0 at its peaks and valleys. Slope as a function of position. Why does a model care about slopes? Because the derivative points the way to better. If the derivative of the error is positive, nudging a little smaller reduces it. If negative, nudge larger. The sign says which way, the size says how far. Every learning step is a derivative, telling the model which direction to move. So, the derivative. The slope of a curve at a point, found by letting a secant line collapse into a tangent. It is itself a function, giving the rate of change everywhere. And its sign is the compass that guides all learning. Next, the shortcuts that make derivatives easy and the chain rule, Chapter 14.